Hi, my gems. Today we're going to talk about trigonometric ratios, and so I'm going to introduce what those are, what they look like, and how we use them in the real world here. So there's three different types of trig ratios that we're going to focus on today: sine, cosine, and tangent. But before we get going on our notes, I'm going to show you guys a cute little quick video of trigonometry being used. I guess you could call it in the real world. But it's on a quick little TV show here, so we'll watch this really quickly. Okay, so what this is here is just an example of some trig, I guess, really kind of in the real world. We use trigonometry to help us figure out either like the length of the side of something, or we can do it for the angle of, it's called elevation or depression. And so that's kind of what we use trig for. So we're definitely going to need a calculator today. So if you don't have one, you're going to need one. And it has to have like multifunction. It can't just be a 4-function one. You can't use your phone, but it has to be off portrait mode if you're going to use it. So there are three different ratios or trig ratios that we use. So a ratio is just a fraction. And there are three different ones that we use: sine, cosine, and tangent. So the first one is called sine. And what we have to do to start is we always have to pick a reference angle. And the reference angle is the one that we are looking from that angle to the other side lengths. And so depending on what the reference angle is, your ratios or your fractions are going to change just a little bit. And so in this particular problem, you'll see all of mine say the sine of A, the sine of A, the cosine of A. So in all of these problems, I'm using angle A as my reference angle. So what I like to do is I always like to highlight my reference angles as I use them, because it makes like thinking about your perspective from that angle a little bit easier if it's highlighted. So this angle A is called the reference angle. And you have to have a reference angle to do these trig ratios. So the sine ratio is, it looks like there's a little saying we use, it's called SOHCAHTOA. And so the SO stands for, you take the sine is the opposite side over the hypotenuse. Now, if you're looking at this triangle, the hypotenuse is always the side that is the longest side, and it's the side that is always across from the 90-degree angle. So if I look at here's my 90, if I go across from my 90, this side length right here is the hypotenuse. And so I always mark that first, because I don't want to ever get it mixed up with anything else. So the sine ratio is you take the opposite side and you divide it by the hypotenuse. So in this particular picture here, if I'm looking from angle A, because angle A is my reference angle, the opposite side, or this side that is directly across from angle A, is this side length over here, BC, which is really, it's this little, it's the lowercase letter a here. Okay, so it's opposite over the hypotenuse, and the hypotenuse over here is C. So we're making a fraction or a ratio to figure out what that angle measure is, or what those side lengths are going to be. So the first one is sine. So let's do an example using the sine ratio. So in each of these, we're going to figure out these unknown side lengths of these right triangles, and we're going to solve it using the sine ratio. So in number one, the first thing I need to do is I need to figure out which one is my reference angle. And your reference angle is the one that's given to you that's not the 90. We can't use the 90 when we're doing sine, cosine, tangent. So in this particular problem, my reference angle is 58. So maybe you want to write that down next to it. Reference angle is this 58. Before I do anything, I'm going to label the side that is the hypotenuse. That is the longest side. So the hypotenuse is the side across from the 90. So it's right here. It's the 17. This is my hypotenuse. And the sine, again, is I have to take the side that is opposite of the reference angle and divide it by the hypotenuse. So here's my reference angle. Directly across from it, the opposite side is the x, and then my hypotenuse is 17. So that's going to be my ratio. So here's how I write it. The sine, and we don't write the whole thing out. SIN is not sin, it's sine. The sine of my reference angle is 58 degrees. The sine of 58 equals the opposite over hypotenuse, which is x over 17. Now, this is just a, this is essentially a proportion. What you can do is you can take the sine of 58, put a 1 underneath it, and then we can cross multiply like we have been doing in the past. So x times 1 is just gonna give me x, obviously. And x is gonna equal whatever the sine of 58 times 17 is. Now, the sine of 58 is a number, and so we're going to put it into our calculators, and here's how we do it. We push the number first, so I'm going to push 58, and then there's this little button here that says SIN, that stands for the sine. So I just push that button, and the sine of 58 is 0.84. I'm then going to take this number, I'm going to leave it in the calculator so we can keep it exact, and I'm going to multiply it times 17. So times 17. So the length of this side length right here of side x, the opposite side, is about, and we'll round to the nearest 10, so just to 1 decimal place, it's about 14.4. And there you have it. We just found a side length using the sine ratio. So all these ones on the left side of my flap here, these are all for side lengths. Okay, so let's try number 2. First thing I have to do is find my reference angle. My reference angle is the one that is given to me. That's not the 90. So my reference angle is the 49. Directly opposite of the 49, right across, is 52. So this side is my opposite side. And my hypotenuse is the side across from the 90. This side is my hypotenuse. So the sine of my reference angle, the sine of 49 degrees, is opposite over hypotenuse, so 52 over x. Okay, and then I put a 1 underneath, and then I cross multiply just like I did before. Now this time it's a little bit different. 52 times 1 gives me 52. Equals x times the sine of 49 is literally x times the sine of 49. Okay, now if this was a regular algebra problem, to get x all by itself, for x I'm trying to solve for x, I want to get everything that's not the x to the opposite side. So since this is multiplied by the sine of 49, to get rid of it, I have to do the opposite, which is divide by the sine of 49. And whatever I do to one side of the equation, I have to do to the other. Okay, so this would cross off, and once I put this in my calculator, that's going to be the answer to my equation. So the sine of 49, that should really be the first thing that I put in my calculator. So again, I'm going to push 49, oops, sorry, 49, and then I'm going to push the sine button. So the sine of 49 is 0.75. So I have to do 52 divided by 0.75, and that will be my answer for x. So 52 divided by 0.75. The length of x is about, oh, did I push 45? I put, wait, 49 times 0.75. Okay, 52. Okay, so it's about 69.3. I'm sorry, thought I pushed the button wrong. Okay, so x is about 69.3. Okay, there we go. So we found some unknown side lengths using the sine ratio. Okay, now I'm going to close it up. We're going to do the next ratio. So sometimes you're not always given the opposite and the hypotenuse. So because you might be given different pieces of the triangle, we've got different ratios for it. The next one is the cosine. So my reference angle is angle A, and I'm going to highlight it here. First thing I'm going to mark is my hypotenuse. That hasn't changed. It's across from the 90. So the C is my hypotenuse. Cosine over here, the ratio that we use, so the SOHCAHTOA, the ka part stands for A over H. Now the A stands for adjacent, which means next to, and then the H stands for hypotenuse. So if I'm looking at angle A, the side that is next to this angle A right here, that is not, you can't pick the hypotenuse, so you can't pick C. So the only one that is next to angle A or touching angle A is this piece B right over here. And then I divide that by my hypotenuse, and my hypotenuse was C. So it's adjacent over hypotenuse. So let's try a couple examples of finding the sides using the cosine ratio. Okay, so I'm going to start by highlighting my reference angle. Notice I'm doing the same thing over and over again, never stops. Okay, there's my ratio, or sorry, my reference angle. Across from the 90 is my hypotenuse. And then obviously the only one that's next to the 67 that's left over, the X, that is my adjacent piece. So we set this up by saying the cosine of my reference angle, so the cosine of 67 equals adjacent over hypotenuse. So X over 15. All right, and then just like the sine ratio, we're just going to cross multiply. X times 1 is X. 15 times the cosine of 67 is 15 times the cosine of 67. And now this becomes a problem for my calculator. I'm going to show you now on the phone, just in case you're using your phone, like if you're at home, you don't have a real calculator for this. Okay. Still the same thing, when you go to put the cosine of 67 into your calculator, you do have to push the 67 first. So I'm going to push 67, and then you should see sine, cosine, tangent right over here, not the ones with the H, the one right above it, just says regular cosine. So you'll push that button. That's the cosine of 67, and then I have to multiply that times 15. So it's almost like we're essentially, when we go to put this in the calculator, we're pretty much going like completely backwards. We're really going from right to left when we put it into our calculator. So my answer for this one is the length of side X is approximately, we can round that to 5.86 or 5.9, whatever piques your fancy. Okay, so that side length is 5.9. Easy peasy. Let's do another one. Number 5. Start by highlighting my reference angle. Okay, I'm going to mark my hypotenuse, which is across from the 90, so that's the X. And then this 21 has to be, it's right next to it, so this is my adjacent piece. Okay, so we'll set up my ratio now. The cosine of 34, that's my reference angle, equals adjacent over hypotenuse, so 21 over X. And then again, cross multiply. So 21 times 1 is 21 equals X times cosine of 34 is X times the cosine of 34. Okay, now to get X by itself, I would have to divide both sides by the cosine of 34 degrees. So do the same over here, cosine of 34 degrees. Okay, now The last time what I did was I did cosine of 34. I figured out what that number was. I wrote it down, and then I did 21 divided by that number. So we can do that again, or you can also put the whole thing into your calculator, but you do have to be very careful because your calculator can get like a little bit finicky depending on the order that you put it in. So if you, want to put this into your calculator, here's how you would do it. If you've got this calculator, or if you're doing it on your phone, you would do the same thing. You would push 21 divided by, now when you go to put in cosine of 34, you have to put the opposite in. So you'd have to put 21, let me zoom out so you can really see this here. Okay, 21 divided by 34 cosine. Now that's just cosine, that's just the 34 cosine. That is not the actual division yet. Now you have to push the equal symbol, and that's your answer there. Okay, so we pushed, on our calculators, we pushed 21, then we pushed divided by, then we pushed 34, then we pushed cosine, then we pushed equal. Ooh. So you have to go in that order, otherwise it's not going to be right. So my answer for this problem was about 25.3. So side x is, oops, it's about, sorry, 25.3. And since we are rounding for all of them, we are making sure to put the about, like the approximate symbols, right? Because it's not the exact answer here. Okay, next one, last one. So we've got sine, we've got cosine. Last part is the tangent. So the TOA part of SOHCAHTOA. And I'm sure you can probably figure it out, but, excuse me, here's my reference angle. TOA is O divided by A. O stands for opposite, and A stands for adjacent. So this time we are not using the hypotenuse. I still like to always mark it so that I make sure not to use it when I'm doing these problems, and that might be really helpful. So opposite over adjacent, across from the A is the lowercase a. And next to, so this is the opposite, and then next to it, adjacent to it, is the B value. Okay, so we'll take that ratio now, and we'll find some other side lengths using this final ratio. So setting them all up exactly the same way I set up the other ones. Here's my, whoa, I just hit my head. Here's my reference angle, 38 degrees. I'm going to mark the side lengths. So across from the 90, this side is my hypotenuse. And even though I'm not using it, that's okay. Across from the 38, the opposite side is the x, which means the last side that's left over, the 10, is the adjacent side. So I write it as the tangent of 38 degrees equals opposite over adjacent. So x over 10. Hopefully you're noticing it's just a lot of like proportions again, which is all that we did last chapter when we were talking about similar triangles. We're still doing, essentially, trigonometry is just ratios of a triangle. So it's a lot more just like proportions again. Okay, I'm off my soapbox. So now I'm multiplying, cross multiplying. X times 1 is x. 10 times tangent of 38 is 10 times the tangent 38. And now I put it into my calculator. So remember, you're essentially going backwards. So 38 tangent times 10. My answer is about 7.8. Okay. Last one for the side lengths, same idea. Here is my reference angle. Hypotenuse is across from the 90. Opposite of the 54 is the 17. And adjacent is the x. So I set it up as tangent of 54 equals opposite over adjacent. So 17 over x. Put a 1 underneath, and then I cross multiply. 17 times 1 is 17 equals x times the tangent of 54. And And to get x by itself in this algebra problem, I divide both sides by the tangent of 54. So this is where I put it in my calculator, and remember to push the equal sign. So I'll do it on my phone, this one, just so that we can kind of get like a visual of how they both work. Okay, if I'm putting this into my calculator, I'm gonna push 17 divided by, and then remember I have to push 54 tan equals 54 tan equals, my answer is about 12.4. Okay, so what we just did were sine, cosine, tangent, the regular trigonometric ratios. You just did some trigonometry, give yourself a pat on the back. We just did the 3 ratios to find unknown side lengths of a right triangle. We're now going to take the same idea, except this time on the right side, what we're going to do is we're going to find the reference angle this time. So all the ones we did on the left side here, all of these we're solving for the side lengths, and now over here on the right, we're going to solve for the reference angle. So we're trying to find the reference angle. Now, because we're trying to find a different part of the triangle, we're going to push a different button on our calculators. However, we're still going to use the same ratios themselves. So you see you've got over here the sign with this little -1 symbol next to it. So if you look at your calculators, above the sign symbol, there in yellow, there's a little -1. So you'd have to push shift and then sign. And on your phone, if you're using your phone, to get to the ones with the little -1, you actually have to push the second button and then you can push it. So we use the little -1s when we're trying to find the angles. We'll use the regular sine, cosine, tangent when we're trying to solve for the side lengths. These are called the inverses. So when I say the inverse sign, I mean the sign with the little -1 next to it. Okay, so let's give these ones a try. So if I look at, here's my reference angle, right? So that's what I'm trying to solve for this time. I'm going to label my side lengths. I see that across from the 90, this is my hypotenuse. And the 37 is directly across from the x, so this is my opposite side. So I know that obviously I'm telling you which one to use here, but if you were trying to figure it out, you would say, okay, I'm given the opposite and the hypotenuse of these ratios, which one uses opposite and hypotenuse, and obviously it's the first one, but that's how you would go about choosing if you didn't know which one it was. Okay, so we're going to use the sine. Now we're going to set it up the same way, except this time we're going to write the inverse sine of my angle. So you're trying to figure out what your reference angle x is. All you have to do is take your ratio and write it out. So your ratio is, remember, so is the O over H, so it's opposite over hypotenuse, so it would be 37 over 44. So what we're going to push is the inverse sine of 37 divided by 44. So here's how we do it. Easy peasy. You will take the fraction and you'll put that in your calculator first. So 37 divided by 44. And you'll get a decimal, right? And so now from here, with that decimal in the calculator, you'll push shift sign, or second sign if you're using your phone calculator. So to the nearest degree, angle X is about 57 degrees. That's it. So X is about 57 degrees. So I like these more because it's way easier. So let's just write down though, like what we put into our calculators or our phones so that we remember. So to put this in our calculators, we first push 37, then we pushed divided by, then we push the bottom number 44. Afterwards, we push the equal sign. Then we got our number, right? And then we pushed shift, or if you're using your phone, you pushed second, and then you pushed the last part was sine. And that's it. You didn't have to push an equal sign after that, okay? Whew. So that's a lot there, but again, it's like putting everything in essentially backwards is how you really use these calculators, which is kind of interesting. Okay, let's try the next one, number 6. Find the value of x round to the nearest degree. Okay, so this is my reference angle. This is what I'm trying to find. Across from the 90 is the hypotenuse. And this 14 is directly next to the x, which means this is my adjacent piece. So again, I know that it gives you the answer there, but I would say to myself, okay, which ratio uses adjacent and hypotenuse? Well, that would be the cosine ratio. So I'm going to use cosine for this problem. So to figure out what x is, I'm going to take the cosine, excuse me, look at me, I already about to say the wrong thing. The cosine of, and so it's cos, so SOHCAHTOA, so it's a over h, which is adjacent over hypotenuse, so 14 over 18. Okay, so let's put it in our calculators. Remember, we're going kind of backwards here. I'll do this one on my phone, so you've got an example. Okay, 14 divided by 18 equals 0.7, repeating, and then you push second cosine with the little -1, so inverse cosine. You get angle x is about 39 degrees. 39 degrees. I think that's right. 14. I think that's wrong. No, that's right. Okay. About 39 degrees. That's it. Easy peasy. All right, one more. Last one is a tangent one. So I'm trying to find, again, here's my reference angle. Across from the 90 is the hypotenuse. There's nothing there. So I'm not going to use the hypotenuse in this problem. Across from the x is 11, so that's the opposite side. And right next to the x is 18, that's the adjacent side. So you do have to mark up the triangle before you can do anything. Without marking it up, you're not going to get it right. Okay, so this one, since I'm trying to find an angle, I'm using the inverse. And to find tangent, it's TOA, so it's opposite over adjacent. 11 over 18. Okay. So again, we put in our calculators, 11 divided by 18 equals, we get 0.6, and then I push shift, tangent, I get x is approximately 31 point, oh, I suppose what am I supposed to do to the 1, 31 degrees. Okay, and that's it. So now, you use regular sine, cosine, tangent, the regular ratios when you're trying to find a side length, and then you'll use the inverse ratios when you're trying to find a reference angle. And that's really important that you know the difference between the two. So now you are ready to do some practice with trigonometric ratios, and you just did trigonometry. You thought it was going to be so hard. Hopefully you thought it was really easy. So go ahead and get going on your next practice. Hopefully that was helpful. And I'll stop recording now. Okay, great. Bye, my gems.